Today we're going to look at a few additional examples of graphing logarithmic functions. Now remember, log functions and exponential functions are inverses of each other. So we don't really know right now how to graph logs directly, so we're going to convert these functions or these equations into exponential form, create the table for those, and then inverse them or revert them, the x and the y, and be able to graph them as actual log functions. So let's jump right in. So let's start with y equals log base 4 x plus 1. And when we invert these, we're going to switch the x and y. All right, so that's x equals log base 4 y plus 1. And then our next step here is to isolate this y. Now the y is inside the parentheses, so we can't do anything to it yet. We've got to break it out. So this log is what's keeping it there. Now what's going to cancel out a log 4, remember the inverse, or the opposite of that is an exponent, exponential. So 4 to this log 4 power. But if I put 4 to the power on that side, I've got to put 4 on this side. So log base 4 and 4 cancel. So we've got 4 to the x power equals, and now we don't need the parentheses anymore, so y plus 1. And finally, getting y by itself, we'll subtract 1 on both sides, leaving us with y equals 4 to the x power minus 1. And so now this is in exponential form. And we're going to graph that like we've done before, our xy table. And we're going to use those major numbers, -3, -2, 0, 2, and 3, plugging all those in for x, and we're going to get y values. And we're going to save ourselves a little bit of time. Now, if you plug in all these in, it's 4 to the -3, then that whole thing minus 1. Same thing here, 4 to the -2, and then that whole thing minus 1. Let's go ahead and just kind of display these answers. So -0.98. So check on your calculator, make sure you're getting these same numbers here. We get a 0 here because 4 to the 0 power is 1, and then 1 minus 1 is 0. And then 15 if we plug in 2, and 63 if we plug in 3. Now that isn't the table that we're going to graph. That would give us the exponential graph. What we need to do is reverse these columns. Okay, so we're going to reverse these columns, and that's going to give our log function, the one that we actually want to graph. So let's create that log table. So I'm just going to flip all the values. So now the y's are -3, -2, 0, 2, and 3. And the other numbers, -0.98, -0.94, 0, 15, and 63. So I'm just switching the order of our columns there. And now this is the one that we're going to want to graph. So my x values or my y values range from +3 down to -3. My x values, they range from -1 all the way over here to 63. So this isn't very accurate, but it's going to give us an idea. And then another number we're going to see is 15, so maybe somewhere around there. All right, so let's go ahead and graph these. My first point is -0.98, so almost close to -1 by -3. So here and then down to -3. The other one is -0.94, so again, same kind of area, but down to -2, 0, 0, 15, 2, and then 63, 3. And if we connect these, we've got here slightly growing, and it's starting to flatten out. Okay? So when we do this, we do want to talk about domain and range. All right, domain is our measurement from side to side. Range is our measurement up and down. So range is a little bit easier. Range, this goes continuing down to -infinity and continues up to +infinity. The range, it goes a little bit different. It'll keep going to the right. So the number to the right is +infinity. Will it ever stop going to the left? Let's see. These numbers are getting closer and closer to something. And that number is that -1. You see the numbers over here, 0.9, 0.94, 0.98, both negative. These are getting closer and closer to -1. That's a vertical asymptote there. So -1 is where it starts, and then it goes off to positive infinity. Now let's take a look at another one, and you'll see why this one's pretty significant to us. So our second example here, y equals log base 1/3 x plus 3 minus 1. So you'll notice right away, on the first example, the base was 4, a whole number. This time the base is 1/3. So that 4, a number bigger than 1, or 1/3 smaller than 1, these are going to affect the shape and direction of our graph. Okay, we can tie these back into the exponentials. Remember, a number bigger than 1 was exponential growth. A number smaller than 1 was exponential decay. So let's see what happens to our shape here. But we're still going to do the same process. Switch x and y. And then isolate y by itself. Now this time we can move that -1 first by addition. So it's actually x plus 1 over here equals log base 1/3 y plus 3. And now that y is stuck in parentheses, so now we deal with the log. Just like last time when the base was 4, this base is 1/3. So we're going to take 1/3 and lift that whole thing to that exponent. But what I do to one side, I do the other. Now the exponent is x plus 1. These cancel. So I've got 1/3 to the x plus 1 power equals y plus 3. And then finally subtract 3 to the other side. So y equals 1/3 to the x plus 1 power. And then that whole thing, we're going to subtract 3 from it. Okay? And that's what we're going to create the table from. But that's going to be the exponential version. We'll switch the columns, and that'll give us the log version of it. So -3, -2, 0, 2, and 3. So I'll set the first one up for you. So it's 1/3 to the -3 plus 1 power, and then the whole thing minus 3. All right. Now if we put that in, that answer comes out to a 6. Okay, because that's actually 1/3 to the -2 power. You flip it, that's going to be a 9. 9 minus 3 is 6. So check your answers later on. This one's, you're going to plug in a -2 minus 3, you're going to get a 0. So I'll just kind of move ahead. This one's going to give me a -2.67 because it's 6 continuing, -2.96 and -2.99, and you can kind of see that we're approaching a -3 here. Okay, and that's going to be our asymptote later on. Remember, our next step now is to switch these columns. So the actual log graph that we're going to create, so the numbers that we chose are going to go on the right now, and the output values that we got are going to go over here. So 6, 0, -2.67, -2.96, and -2.99. Those are the ones that are going to get put on the graph because remember, these are new points. So we need to range these numbers up and down from +3 to -3. I can space that better. There we go. And then my numbers are ranging from 1, 2, 3, 4, 5, 6 over here, then back to 1 to -3, +6. Okay, so we're going to go ahead and graph these points now. My first point is 6, -3, so 6 over, -3 down. Next one is 0, -2, -2.67, so a little bit bigger than 2.5 by 0, -2.9 by 2, so it's getting closer and closer to 3, not quite touching it, but getting closer and closer. So we see the curve here. So different than last time, here we've got a log that's now going downwards. Okay, I'll fix that point. Oops. Fix the whole thing. All right. So it's still approaching this -3. That's still the vertical asymptote at -3. So you'll notice, and I'll zoom back up to the other one. If the base is bigger than 1, you're getting this upwards curve for a log. If your base is less than 1, you're getting the downwards curve. But we can still fill out domain and range on this. So my domain and my range, let's see, has range changed at all? It continues going up, it continues going down, so that's all real numbers. For domain, does it ever stop going to the left? And in fact it does. It gets closer and closer to this wall number here, so -3. Does it ever stop going to the right? Nope. Goes off to positive infinity. All right, so the big thing to see today is that base number. Positive or numbers bigger than 1 are going to go upwards. Numbers smaller than 1 are going to go downwards.